above there. Hopefully you've already had a little look at the notes page, and I've just got the first page there, which we're going to talk a little bit about, and then we're going to do a couple of examples together. And when we're doing histograms, just remember that they're not bar charts, even though they look the same. Just try and answer the 3 key questions, which are above. What is frequency density? Why are histograms different to bar charts? And why is area so important? So we'll start with the last of these questions. Let's imagine I was looking at this bar that I've just shaded in. This is a group that goes from 30 to 35. And when we look at that, the height of it is only 10. But that doesn't mean, if that was a bar chart, that would mean there are 10 people in that group. But this isn't a bar chart, it's a histogram. So instead of saying it's 10 high, there are 10 people in this group, we look instead at the area. So when we look at this, the height may be 10. But the width of it from 30 to 35 is 5. So that bar there is 5 by 10. It's a rectangle. And as we know from any rectangle, if I was to just draw a little rectangle, there's my little rectangle, if it's 5 by 10, the area would be 50. A chart like this one here, but you can also see ones that don't have the same width. So you might have long, tall bars, short, fat ones, and everything in between. Another thing to remember is if you look at this group here, okay, it says more than or equal to 30, but less than 35. So technically 35, if you had a 35, it would go in this group here. But we just put the line between them because for histogram's sake, we just use the line between the bars as like a up to here and carrying on, just to show that the groups are separated. But don't worry too much about the less than and equal to or less than symbols. That's not so important with histograms. So let's have a look at one together. Just going to turn the light on, it's a bit dark in here. Hold on. That's better. Okay, it's a bit shiny. I'll stand in front of it. So, that light is very bright in the mirror, but we'll just have to deal with it. The first one here, you've got a load of values, and first of all, to make a histogram, you have to have things in groups. So even though we've got all these individual results, we can't plot them as in individual lines. That's something totally different. That would be like a scatter graph or something else. We're not doing that, we're doing groups. So the first thing we need to do is decide to put them in groups. In this first example, we're going to look at one where all the groups are the same size. So I'll split them up into groups of 5, 15 to 20, 20 to 25, 25 to 30, and so on. Then all you need to do is say, well, how many are in each group? So for example, 0.44 would go in the group of 40 to 45. When you've got ones on the line, this is what we were talking about a second ago, be careful. So like 0.40, that would go in the one that is 0.40 up, because this here doesn't include 0.40. So it doesn't go in this one here, it would go in the one that starts at 40. Okay, so just be careful with those. And you'd keep filling that in until you knew how many went in each group. And I'm just going to jump ahead a little bit. Okay. When you fill in that table, it would look something like this. So there'd be 3 in the first, 4 in the second, 15 in the third, and so on. Now, because all of my groups are the same size, and this is really important, when they're all the same size groups, they're all 5 wide, we don't need to worry about what we call frequency density. We can just plot them all as how many there are, because all the groups are the same size. When it's not, we'll see in a second, you have to do something different. So the first one we can see in the first group from 15 to 20. So I'm going to do a nice thick pen so you can see this. I'll do it in a nice bright colour. So the first one, it starts at 15 and it goes to 20. Well, first of all, we know it's going to go 3 high, so we go 3 boxes up and across. Ooh, that's a terrible one. And down. Notice that the height is 3, okay, because the frequency is 3. But we've gone from 15 to 20. We start at 15, we go to 20, and we stop. Okay, the next one starts at 20, goes to 25, and is 4 tall. So we go up 4, across, and down, and then again we'd shade it in. So when the groups are the same size, it's actually okay just to say, you know what, we're just going to plot the frequency like a bar chart, and we keep doing that as we go along. Now when we've got a frequency density and we've got different sizes, this is when it gets a little bit more complicated. So Let's look at another example now. We've got a group with different sizes. The first group is 0 to 40, so the width from 0 to 40 is of course 40. But the next group is only 10 wide, and 10 wide, 10 wide, and 30, from 70 to 10. So each of these groups has a different width. So when we plot them on the graph, the first one's going to be very wide, and the 10s are going to be very narrow. So then we have to talk about something called frequency density, which is where instead of saying exactly how many there are, we say, okay, well, I'm going to look at the area, not the height. How do we work this out? Well, very simple. We know the frequency essentially is going to be the area, because the area tells us how many we have. We know that the width is going to be the width. So here, the width would be 40. So essentially what we're doing for the first one is we're saying, this is the area, and this is the width. So we're saying, well, we need to know 40 times the height is going to be the area, which is 5. To find this, we divide the width by the frequency by the width. The area by the width gives us the height. And as you can see here, if we do 5 divided by the 40, it gives us 0.125. And that will be the height of my bar. Because if I times the height, which will be very short, and the width, which is very wide, the area will be 5. So for each of them, you take the frequency, and that's going to be the numerator of your fraction. And you divide it by how wide the group is. From 40 to 50 is 10 wide. From 50 to 60 is 10 wide. From 60 to 70 is 10 wide. From 70 to 100 is 30 wide. We use our calculator, although most of the time this would be a non-calculator question, but these should be reasonably straightforward. 6/10 is 0.6, 8/10 is 0.8, 4/10 is 0.4, and 2/30 or 1/15. You don't need to simplify the fraction because you're going to write it as a decimal. It's going to be about 0.066 recurring. So you could put 0.07 if you wished. So once we know those, we can then use those to plot the graph. Now the first one is the hardest. You can see that now on the frequency density it only goes up to 1.0 and each little square is 0.1. That's because we're going to have very wide boxes which are going to be very, very short. The first one goes from 0 to 40 and the height is 0.125. It's going to be hard for me to plot it perfectly because I'm on an iPad, but we'll go with it. It's going to be about there, 0.125, and it goes all the way across to 40. And you can see it's a very, very short, wide box. That represents 5 people. The next one is going to be thinner, but it's going to be taller. It represents 6 people, but it's only 10 wide from 40 to 50. But it goes up to 0.6. So again, we go up to 0.6, across and down. And then, just to make it easier to see, we shade it in. So even though that represents only one more person, it's a lot taller, but it's a lot thinner. But the area is 6. We keep plotting this, so let's do the next one. It's 0.8 by 10, so of course it goes across at 0.8. And finally, let's do it in a pink. The last one is only worth 2 people, but it's 30 wide. So it's a very, very wide box, but it's only going up 0.06. So we need a very, very low, thin one. So we kind of like that. It's not even a whole box high, which is going to look something like this. Because it's 2 people spread out over a long range from 70 to 100. I'll zoom in a little bit more on that so you can see it. Again, the shading isn't perfect, the lines aren't perfect, but you get the idea. We've got short, fat ones, we've got tall, thin ones, okay, and we've got everything in between. I'm going to shade that one a little bit better so you can see the box a bit clearer. Obviously, you don't need to worry about the shading when you're doing it. I'm just doing that so it's easier to see on the screen. Okay, so tall, thin ones, long, short, wide ones. Okay, just remember that the height is what you need to calculate in your table, and that's the important bit. Okay, so when they're all the same width, like we were doing a second ago, okay, like we did at the start. Okay, oh sorry, this one's confusing because that should say frequency density. When they're all the same width, you don't need to worry so much. Like here, we just worked out the height was just the frequency because they were all the same width. When they're different widths, we have to calculate how tall they're going to be because we've got different size bars. And that is histograms, and that's how they look. Have a little go at these. Remember, this is mostly a non-calculated skill. It's not a huge number of marks. Generally, like you'll see on the GCSE questions, it's like fill in a bar and read one off. I think the more you try, you'll find this isn't too bad.